All right, so this is an example of a mass problem. First thing we want is to write our equation into, this is the same one we've been using a lot of lately, just for time's sake. Okay, so we're going to need a 2 here and a 3 here. All right, so what I would suggest that you do on the SOL or any problem that you have is first of all identify where you start. Okay, where is our measure number and with what compound do we have a measure number of? Our measure number is 3.5 grams of ammonia. This is ammonia. So I'm starting at mass, given mass of a substance A. Second thing I have for you to do when you start this question is to underline the place that you want to go to. What is the question? What's the question asking? Okay? And we want to go to, this is our unknown. I recognize that hydrogen gas is different than ammonia, so that's B, and we want to go to mass of B. So, we know on SOL, we label this not a mole A, mole B, you know, this is a mass A to mass B problem. I told you there's 3 simple steps. We'll convert the moles by dividing by mass A. Second step, so when you do your homework, you will mimic exactly what I'm doing and practice it. That way you will, through repetition, you will get an understanding. And so the second step would be multiply by the mole ratio. And then the third step is to multiply by mass B. So now you must understand how to do those parts. So starting like given, 3.5 G's NH3. The first conversion is divided by the mass of A. So I have 1 mole of NH3. Now what's going to change in your homework is that compound. It's the same step, it's just we may be done with a different compound. So 1 mole NH3. Now I'm going to calculate the mass of NH3, and I'm going to do that in my head. We should know that by now, it's chapter 10. The mass of NH3 will be 1 times the mass of N, which is 14, times 1, so it's 14, plus 3 times the mass of H, which would be 3 times 1 is 3 more. 14 and 3 is 17 G's. Okay? So then I get my answer, 3.5 divided by 17.
How come on the 1 mole of NH3, why wouldn't it be 2?
Why would you have 2?
Because it says 2 NH3 in the equation.
Okay. 2 NH3s would be 34. You agree? Okay. So the first step has nothing to do with the balanced equation, the recipe. The first step is to convert to moles, chapter 10. If I'm given 3.5 grams of NH3, how many moles is contained in that grams? Okay? So we don't, this has nothing to do with the number of moles in the balanced equation. That's step 2. Now when we go to mole ratio, we'll have to include the 2 moles of NH3. Because then we're saying there's like 4 cups of butter to 2 cups of sugar. Right here is chapter 10, the last test. If I give you 5 grams of Na, how many moles is it? That's all this is. This has nothing to do with, the only additional step that we learned in this chapter 12 is this mole ratio, and that's the only place that you include the coefficients. Okay? So the answer to your question is, why do we just have 1 mole? Because 1 mole, 1 of NH3, 1 apple, is 17 grams. We have to use that to get the moles. Yeah, does that answer your question? All right. Okay, good question. So then we go to mole ratio. And in the mole ratio, if NH3 is here, NH3 must go here. And so then I look at the balanced equation. 2. 2 moles of NH3 there. What substance do I want to go to? H2, right here. So that goes to the top. We write 3 moles as H2. We write 3 moles of H2 there. So 0.205 times 3 divided by 2. Give me 0.308. Okay, now because I don't have room, you just keep going on out. Because I don't have room, I'm going to come down the bottom. And so 0.308 moles of H2. The last step is to multiply by the mass of B. So then, what's this? This is the question that Katie had. How much does 1 H2 weigh? Because that's the mass, that's the standard mass that I multiply. So then, 1 H2 would weigh 2.0 grams, 2 times the mass of hydrogen. That's what we 0.61. 0.616. So our answer here